So number 1a, the square root of 169 is 13. There's no tricks there. B, square root of 4 over 81. You might think you can do that with a calculator, but what times what equals 4? 2. What times what equals 81? 9. So it's just 2 nines.
9.
Okay, C, square root of negative 49. 7i, but the directions say if it's not real, state so. So we're just going to put not real.
Why is it not real?
If it's imaginary on this part, the top part, they want us to just put not real. Okay, number 2, you could just do a calculator. 2 is just cube roots instead of square roots, but you can use a calculator. Does 2a have a real solution?
Yeah.
Yes, because you can't have a cube root of a negative because 3 negatives do multiply to get negative. So 2a is real. There is a number. And like I said, it is real. Number 3. 4th root of 729. Well, you could try to use your calculator on this, but it won't come out pretty. It'll spit out a decimal. So what should we do instead? Why can the calculator not handle this one? Because it doesn't come out perfect and because it's not a square root. So how do we do it without the calculator? The tree. So you got what goes into like 72 and 9? 9. So if you do 729 divided by 9, that would be 81. 81. And you keep breaking it down until they're all primes. 81 is 9 times 9. Alright, you guys remember how this works? This is a 4th root, so to escape the jail, you need to have at least 4 of them. Well, exactly 4 of them, I should say. So there is 1 3 that's going to escape, and what's left behind? 9. 3 times 3 is left behind. So 9 is left behind. Alright. Wait. Is this got A, B, C? Doesn't. Okay, that was A. The B is the 4th root of negative 81. Is it possible to have the 4th root of a negative? No. 4 negatives multiply to get a positive, so there's no way that you can get a 4th root of a negative. It's not even an I at that point because it's not a square root of a negative, so I don't know. We haven't defined it. 4th root of 10,000 for C. Can you guys do that one without a calculator? Yeah, because 4 10s multiplied together gives 4 zeros. So anyway, it is just a 10 on that one. No, chances are like less than 1%.
Yeah, it's still a chance.
So you're saying there's a chance? Friday's got like a 20% chance of out of school. There's a good chance we'll get a dusting of snow tomorrow. That's not what I'm saying. But there's almost no chance we'll get out. Number 5, cubed root of negative 72x to the 5th. Okay, we are simplifying. So, can we simplify cube root of negative 72? Is it possible to have a cube root of a negative?
Yes.
Yeah, it is. It'll just be negative something. I'll throw the negative out there. But how do I simplify cube root of 72? With a tree.
Oh yeah. Oh yes.
Okay, since it is a cubed root, because it's a cubed root, we need 3 of them to get out. So I see a triple 3. So the 2 is going to get out, but the 3 is left in the cubed root. Okay, and notice I left a little space right here. You guys know why I did that? Okay, how did we simplify cubed root of x to the 5th? Yeah, we did 5 divided by 3. How many times is 3 going to 5? once with the remainder of 2. Okay, so what that means is 1x is going to come out and 2 are left behind. It's been a while since we've done that. You guys remember that?
Yes.
We had a quiz like 4 or 5 weeks ago on this stuff, right before we started studying for the final.
How is it not 9?
You should remember that.
How's it not 9? Oh, you're right, it is 9.
Okay.
My bad.
Racism.
It's not 9 because I forgot what I was doing. That's why it's not 9.
That's the one thing I thought it was true.
One thing is for
She's
certain.
so smart.
I'm interested in one thing.
Oh, that's not.
It's not racism. Shane.
Listen.
Okay, number 7. These are basically the same thing. 4 through 9. You treat them the same. 27, a to the 5th b. Okay, square root of 27. Can the calculator do that part? Yes, because it's a square root. But square root of 27 is going to come out as 3 square root of 3. I'll leave a little space right there. Okay, so for the a's, if there is no root written right here, what root is right here? 2. If there's no power on the b, what power is on the b? 1. So for the a's, we have to do 5 divided by 2. How many times does 2 go into 5? Twice. 2 times 2 is 4, with the remainder of 1. So that means 2 a's come out, and 1 is left behind. How about the b though? How do we do 1 divided by 2? Okay, it doesn't really simplify. 2 goes into 1 0 times with the remainder of 1. So that means nothing comes out and the 1 stays inside. So if there's not enough to divide, like 1 doesn't, has to have at least 2 divided by 2. It just stays there. The b didn't really move at all. Stayed inside the square root. Alright, that's so anyway, that's the answer.
Wendy's sounds kind
What did you do today?
of good. Wendy's.
Oh.
I wasn't even joking. It does sound good.
What sounds good?
Oh, Wendy's.
Wendy's?
Yes. Wendy's.
Shannon, shame on you. Shame.
Keep moving.
Guys,
Keep
it's so
moving.
funny.
Wendy's.
Scott said she
For
saw you in your
dominant.
dress.
Yeah.
Yeah.
You've been dominated.
She remembers your order.
She told me she forgot it this morning.
You got that doll. I don't think you understand.
Yeah, so I pull up in the drive-thru and Skylar like opens the window. I'm like, hey. She's like, hey. And she closes the door.
I'm you in that man.
Anyways, how do you do the cube root of a decimal? They're only going to give you a decimal if it comes out perfectly. So you can just like use your calculator. But do you guys know what the cube root of 125 is? 5. So this is, if you plug in your calculator, it'll come out as 0.5 because it is a decimal problem. But so as far as the number goes, you just use your calculator. So what about the x's though? 4 divided by 3 is 1 with the remainder of 1. So 1 comes out, 1's left inside. Alright, for the y's we have 6 divided by 3, 2 with the remainder of 0. So 2 come out and no y's are left behind. So that's it.
The X is on its own.
X is by himself.
So we don't really need to show work on these sections.
Shit. Man, can you shut up?
Listen,
No, there's no more.
Go back to where you came from.
yeah.
My Germany.
But kid.
I like it full of nose.
Austria.
Forrest, did you not even hear me say?
What?
Where are your families? Where's your family from?
My dad's from Croatia. And
Like-
Look at this one.
I just think a lot.
No, that ain't no.
Are you serious? He was born in Germany, but he's from Croatia. Oh, dang.
He's actually born in Germany,
Yeah.
like as a military kid or like as a German?
As a
I want
German.
your honest.
My grandparents
Hey,
lived
this is
in
my friend Texas.
He's, yeah.
These are can you smell something?
He's an immigrant. It's not he is.
Does
You're
he,
an
does he,
immigrant now.
is he fluent in German?
I do have a
Yeah,
strange
and
dislike for
Croatian.
this
Do you know I
man.
still put stars on these people?
Yeah.
Does he have an
You know
accent?
what's happened to this boy at birth?
No, he doesn't.
Yes, he does.
Yes, he does.
You know how big his nose is?
No, he doesn't.
That's where it is.
So
Thank you.
I've
Nice to
seen
meet
him like
No,
walking.
that's what I like thought. Like, the Nazis.
Stop.
Okay,
Okay.
here's the thing. On this section, we are not simplifying. We are rewriting in exponential form. So in other words, we're getting rid of the radical and writing everything just inside the exponents. Okay, if you have a number like 25, they do want you to break it down. 25 is just 5 squared. Okay, so you guys remember how this works? A, for example, would be a to the what power? 3/4. So the 25 will become 5 to the 2/4, which reduces to 1/2. Okay, so you just put 5 to the 1/2, a to the 3/4, and b to the, yeah, I heard somebody say 1/2. B to the 2/4 or 1/2. Whoops, I put a again. Alright, so that's called exponential form because all the information is like inside the exponent. Alright, on 13, they're going the opposite direction. They start in exponential form and we want to change it back to radical form. Actually, instead of 13, 12 is a little bit harder, so let's do 12 instead. 2 to the 4/3, a to the 1/6.
Okay, I see what you mean.
Okay, so the 3 and the 6 mean that's the root. But to be in the same radical, we need the root to be the same. So how do I make 3 and 6 the same? What do 3 and 6 both go into? 6. So I'm going to multiply these by 2. So it becomes 2 to the 8/6,
Okay.
a to the 1/6. Now the 6 tells me what the radical needs to be, or the root, I should say. So it's the 6th root. Okay, 2 to the 8th is what would go inside, but 2 to the 8th simplifies. 2, 4, 8, 16, 30. It's like 256, okay? And a to the 1 also goes on the inside, which is just a. $64, $128, $256. The other class we finished through 25.
Why? The run?
25 is weird.
Be honest, be honest.
You're the most racist person in
Yes.
class.
Alright. Yes. That's exactly what. Sorry.
Looks like it was a little bit too much guidance.
No?
Oh, we're not doing 13. I'm gonna jump to 15.
Super hot.
Did
You
you
wanna
stop
do
it?
20?
Yeah, go ahead and do 13, you guys.
Listen.
Oh, never mind.
Okay, now, we could use the calculator on this because it's a number, but what's the 1/2 power mean? Square root. The negative would not be in the square root because it's like order of operations, exponents first. So square root of 64 is 8, so this is -8. 17, 25 to the 3 halves. Okay, so that 2 on the bottom actually means square root. What's the square root of 25? 5. And then you cube that. What's 5 to the third? 125. So I don't really care if you use your calculator or not, I guess. Number 19 is really weird. 16 to the 5/12. For some reason, this is the only one that doesn't come out nice. I don't know why they did this, really. 16, I think they want you to break it down. 16 is like 2 to the 4th. And if you multiply those powers together, which is what you would do, 4 times 5/12, it's 2 to the 5/3. They didn't really say you had to do radical form, so I'll just stop there. We'll call that good.
Okay. And you should have.
I'm holding in my demon spores.
Okay, on number 20, I really wish they would have
I do too.
gave better directions on this part.
Maybe we should just think of it.
The 1/3 power is like what? What's the 1/3 power like?
It's like cube root 2.
It's a cube root. So on 20, just write down the cubed root of 3a squared b to the third. And then simplify, simplifies a little bit. Do you guys get that? So the 1/3 power turns into the cubed root of that stuff in parentheses. And then you can simplify it a little bit, kind of like we did on number 5 or 4 or whatever. Those problems. 21 is kind of easy. Can a calculator do 21?
No.
Yes, it can. When can the calculator not do it? When they start changing it to cube roots, which they will later on. You could do it by hand. Right now, these two don't add together because they're not like terms. Square root of 18 minus square root of 2 doesn't mix. But if you simplify the square root of 18, it's 3 square root of 2. So 7 times 3 is 21 square root of 2. Minus 3 square root of 2 is 18 square root of 2.
You should do it, man.
Take a chance.
Okay, 23. Oof. Just take me a minute just to write it. Should I?
Yeah, that's the group.
Okay, well, what's going to be different about 22 than 21? Okay, you have negatives under the square root, which means what? I. So you could still kind of, even if you don't have the white calculators, you could still get it by removing the negatives from the square roots and then putting I back in the answer. That's kind of the trick way to do it. Or you could use a white calculator.
Uber racist mode.
Or you could just do it by hand. The
Oh my lord, no.
simplify square root of 27, simplify square root of 75, and just put an I inside those, and they'll mix together. 23 was going to take me like a minute to write it down, but I probably need to. I wonder if I copied it down right. No, 24.
Sorry.
Okay, so what do you guys think? Any ideas? How can we simplify this mess? Well, we should try and simplify each term if we can, and then see if any of them are like terms that actually add together. You have to be a like term to add together. So how can I simplify this first term? Okay, what's the invisible root right here?
Oh, those.
2. So remember what we did at the beginning? We did 4 divided by 2, right? So that would be x squared comes out. And then for the y's, what's 3 divided by 2? 1 with the remainder of 1. So 1 comes out, 1 stays in. What about the z? Yeah, not enough z's to divide, so the z just stays there. Okay, so that's the first term. Can I simplify the second term any? We can do 2, for the x's, right, we can do 2 divided by 2. So 1x comes out, but what if there's an x already out there? X times x, x squared. Yeah. And then the yz, there's not enough y's or z's to simplify, so it just stays there. Okay, can I simplify the third term any?
Yeah.
2 divided by 2, just like right there. 2 divided by 2 is 1x comes out, x times the x already there, 6x squared. YZ can't do anything. Alright, are any of these like terms that can be added together?
Yes.
First two, not only are they like terms, they're exactly like.
Yes.
So we have one, they're both x squared y squared yz. They have to be like identical. There could be a number in front that's different, but all this stuff would have to be identical to be like terms. Anyways, we have one of them plus one of them, so we have 2 of them. We have 2x squared y squared yz. And then this guy is kind of off on his lonesome. Hear that lonesome whippoorwill.
That was beautiful. That was nuts.
I was trying to be beautiful horse.
Yes, you were.
Using a tinted mating call.
Oh, okay, hold on.
He sounds like blue.
That's just not good. Ain't nobody coming to that.
Okay, 25 is weird and it'll probably freak you guys out. So,
The sound of
well, let's look. It's actually not very long. It's a short problem, but any ideas?
Is this where we're stopping?
I might do one more. They're not all hard, just some of them are. Okay. Any ideas? Any bright thoughts?
we multiply by
Can you multiply 7 times 3 to the x? No, you cannot. The reason you cannot put those together is exponents come first. So that would not equal 21 to the x. That would be something different. Order of operations kind of prevents us from multiplying those together.
about 3 times 3.
Okay, so it's kind of like the problem 7 times something minus 4 times something. What's that going to equal?
That's a great question.
7x minus 4x is 3x. So if we have 7 of these minus 4 of these, we have 3 of these. Okay? Can we simplify that any? Well, hint, I wrote an equals down, so yes, we can. 3, with it, what's the exponent on this 3? 1. What do we do with the exponents when we're multiplying the same base?
Okay, I see what you're doing.
Add. So this is equal to 3 to the x plus 1. Yeah, that's a weird one. It's kind of just different than any other problem. Let's just put it that way. I won't put it on the test, so you don't have to think. There you go. Lisa, I answered your question before you asked it.
What was my question?
Won't be on the test.
Thank you.
Yeah, let's do one more. These aren't that bad. Uno más.
Is that Spanish for uno mas?
Well, I got you.
Okay, so we're multiplying. Do those multiply together?
8
they do. You can do a square root times a square root. There's no problem there. So 6 times 3, the square root of 18, a squared times a to the third, b to the third times b to the fourth. Guess what? We can simplify it. 18, for example, square root of 18 is going to turn into 3 square root of 2. Okay, what am I going to do with the a? 3 divided by 2 is 1, with the remainder of 1. For the b's, 4 divided by 2 is 2, with no remainder. So this would be the final answer.
Yes. That's what I got.
You have to be kidding me.
All right, we'll call that good for today.